Hey, Dr. Clark coming at you with a Check Your Understanding video. We're in section 7.1 on Laplace transforms. Let's take a look at the problem. It looks to me like they've given us a function here, which is a piecewise function, and they've asked us to make the graph and then compute the Laplace transform using the definition. So first, for part A, you have between 2 and 4, we have a function with a height of 3 units. Maybe I'll make the graph in blue here, and then the graph is 0 elsewhere. So that is part A. It's just graph that function for values of t, 3 between 2 and 4. And then for part B, they've asked us to compute the Laplace transform of that function t. Well, the Laplace transform is the integral from 0 to infinity of e to the minus st times my function f of t dt. And the function f is essentially, at least between 0 and 3, the function is 0. And then between 0 and 3, between 0 and 2, rather. And then between 2 and 4, that function is equal to 3. And then between 4 and infinity, again, it's going to be 0 after that. And so these two integrals are just 0, basically, right? Because the f is 0 on those intervals. So this just leaves us with, I guess if we simplify, we can factor out the 3. 3 times the integral from 2 to 4 of e to the minus st dt. We compute that integral by finding the antiderivative of e to the minus st with respect to t, which is e to the minus st divided by minus s, and evaluated from 2 to 4. And so we have, I guess, 3 over negative s times e to the minus 4s minus e to the minus 2s by putting in 2 and 4 for t, because t is, again, that variable of integration. And you might simplify this down to, I guess, 3 over s times e to the minus 2s minus e to the minus 4s. And that is the answer. And, getting ahead of ourselves a little bit, you might notice a few things. You see this 3 right here. One interesting thing about that 3 is that is the height of the function 3. And then you'll see a 2s and a 4s, and it turns out those are 2 and 4 kind of showing up there. And over time, we'll have a way of computing Laplace transforms like this without using the definition, but this problem was all about using the definition. So hopefully that made sense, and the solution you were able to find on your own. And hopefully this video was helpful for you. So we'll see you next time. Bye.